that all the things are present together. So after your board exam, you can just have a look at this for revision. Okay, so I'll start with this chapter 1, and today I'll not go very fast. This is the first class of this NEET batch. So see, we'll start with a very basic concept we started with, that was electric charge. So right now, don't write, just understand. So the notes are also very important, because these notes will also be in the form of questions. Means the questions that have come previously, whether it's the form of assertion, reasoning, we'll be doing it in the form of notes also. So that's why these notes points are also important. So see, electric charge, we all know it's the intrinsic property of matter. Yesterday, Ibrahim, we discussed it in the class yesterday. Remember, Ibrahim? So it's the basic property of matter that gives rise to different electrical forces. So see, not only electric forces, now you need to have it in your mind that it gives rise to electrical as well as magnetic effects. Electrical and magnetic effects. Okay. So see, magnetism we haven't done till now, but you should keep it in your mind that magnetism is also caused by electric charge. This is one of the factors that can lead to magnetism. So it's a property by virtue of which object or any particle produces electrical and magnetic effects. Now, what all properties are important for you to remember? What all things that you should have it in your mind? If a charge is at rest, if a charge is at rest, it will only produce electric field. Magnetic field will not be there. It will produce only electric field. Magnetic field won't be there. But if a charge is in uniform motion, see, uniform motion and non-uniform motion, I hope you people understand. You are already passed out from class 11th. Uniform motion means when the distance is being changed with the time in definite intervals, means equal intervals of time and equal intervals of distances are covered. That is uniform motion. So if a charge is in uniform motion, then it will produce both electric field and magnetic field. Okay, then it produces electric field and magnetic field. B is the symbol for magnetic field. Now, this was specifically for uniform magnetic field. Rest we have seen, uniform we have seen. What if this velocity is not constant? Means when we say the charge is at rest, see, when we say the charge is at rest, this means this is a charge, let's say Q, its velocity is 0, so it will exhibit just an electric field around itself. But if a charge is in uniform motion, means this is the charge present and the velocity with which it is going is constant. The third case that is possible is if the charge is moving, but in non-uniform magnetic field. So when the charge is moving with non-uniform motion means velocity can be different. Means different time intervals can be there or different distances can be covered. See, speed is distance by time. So either your distance will remain constant and time will change, or time will remain will be constant and distance will change, like this. So if a charge is in non-uniform motion, electric field will be there, magnetic field will also be there, like this, like the second case, but it also radiates electromagnetic waves. This is a third this is the different property of the third point. So if a charge is in non-uniform motion, see, electric field and magnetic field will definitely be there because charge has started moving. So it produces electric field, magnetic field, but it will also radiate electromagnetic wave and also radiate, if a charge, it also radiates electromagnetic wave. So this third case means what? This third case means you have the charge particle present and this is still moving with some velocity, but this velocity is not constant. So these are some different things that you usually don't study in the from your NCRT. But why are we studying it like this? Because see, your magnetism, electromagnetism, and everything, it will come combined in your NEET exam. So you don't just have questions from electric field and electric charges separately. When the exam comes, you will have questions which will relate with your magnetic field, also your electromagnetic wave also. See, we have seen basic properties of charges. Very four basic properties of charges are there in NCRT. Some additional properties we'll study right now. So first copy it down, both of you once done, then you can text me done. I'll start with the properties of charges. Please write. Is it clear, Ibrahim and Jasleen? Clear?
Yes, ma'am.
Okay, please write it.
Mom, here V is electric potential.
No, it's the speed, velocity. Velocity is
Oh,
zero, then only the charge will be at rest. So V is the speed.
so velocity of what? The
Velocity of the charge. Velocity of charge is zero.
okay.
So charge is at rest. It's not
Okay.
moving because there is no speed. Done? Both of you? Okay, Ibrahim, you have also written? Yes, no?
Yes, ma'am. Yes.
Okay. See, amongst the properties of charges, let us discuss this. Properties of charges. So see, basic properties of charges you already know. See, it's a scalar quantity. And when we say it's a scalar quantity, it can be solved algebraically. Apart from this, whenever you have charge, electric charge is that quantity that will tell you, it will represent the excess or deficiency of electrons. When excess electrons are there, we say body is negatively charged. When loss of electrons are there, we say body is positively charged. So when we talk about the charges, they are of two types also. One is the positive group, other is the negative group. So positive doesn't mean it has excess of protons. It means this is deficiency of electrons. This is deficiency of electrons. But when we talk about the negative charge, it means it has excess of electrons. That's why a body is negatively charged. So negative is quite easy to understand. But for positive, you should have it in your mind that it's the deficiency of electrons which is creating this positive charge. Okay, then this is also clear. Like charges, they will be repelling each other. Unlike charges will be attracting. That I'm not writing. One point is important. Remember, charge of an isolated system. Charge of an isolated system is conserved. So it means this is the same definition only that we say charge can neither be created nor be destroyed. It just gets transferred. But what is this isolated system? Isolated system means the net force is zero. There isn't any external forces acting. When we say this force means the external force. So there isn't any external force acting in your system. So the net force is zero. That is what is meant by an isolated system. Okay, so charges of an isolated system, they are conserved. Then you know that charges can be quantized. So you have the equation Q is equal to plus minus NE. This equation is important. And one more thing, class, from where has this equation come? Because in most of the questions, if you see the previous year questions of NEET and JEE, you will find that the question has not directly mentioned quantization. It is indicating you with the help of Millikan's oil drop method. See, this was actually discovered by Millikan's oil drop experiment. Millikan's oil drop experiment. He was actually doing certain experiment using the oil drop. So downwards mg force was acting for the, if this is the oil drop, downwards mg was acting, upwards the electric force, that was QE, was acting. So I gave yesterday I think we discussed this question also. So this you have to remember. Now charge is always associated with mass. Now mass, what are massless quantities? You should know this. See, charges, charge is always associated with mass. Charge is associated with mass. Like when we talk about electrons, the mass of an electron is 9.31 into 10 to the power minus 31 kg. Similarly, you have mass of protons and all. See, what is a massless quantity that is existing is a photon, because its rest mass is zero. So just I'm making a point, I'm writing, if anything is massless, it is photons. Because the rest mass of photon is zero. There's masses depend on the velocity, mass depend on the speed. So that's why when the photons start moving, they become massless. Their rest mass is 10 towards zero. So you need not go into the details. But yes, mass can exist without a charge. See, charges are always associated with mass. One exception I have told you, that if you want to check a massless quantity, it is photon whose rest mass is zero. But in general, charges are associated with mass. Protons have their mass, electrons have their mass. But if I reverse this, if I just shift this, mass without a charge, so masses can exist without charge. Can you give me an example? Think of an element, but masses can exist without charge. Except for this, which I have written, charge is always associated with mass, but masses can exist without a charge. Best example, neutron. Okay, protons have positive plus E value, electrons have minus E and all. But neutron has no charge, but still it has a mass. Right. So there are various other particles also that we need not go into the detail right now. Even if we have to go into the details, we'll see that in the chapter nuclei. Because here in the NEET part, we have to do certain extra things which are not there in your board exams. So masses can exist without the charges, neutron. Is it clear?
Yes, ma'am.
Okay. So one more point is that invariance of charge means charges do not depend upon speed. Okay, this also should be there in your mind. Apart from it, see some things that are important from your NEET exams, numericals. One thing, SI unit, you obviously know. The SI unit of charge is coulomb. This C. CGS unit, Ibrahim, you tell me. Yesterday I told you the CGS unit. Can you tell?
Yes, ma'am. The CGS unit is start coulomb. Start
Yes,
coulomb, yeah?
right. It is stat coulomb. Okay, this is stat coulomb or electrostat unit, which is written as ESU. Now, this we have already done. What is extra in this part? So some things extra you should know. One thing I told you the conversion also, that if needed, you should know 1 coulomb is 3 into 10 to the power 9 ESU. This is important for your numericals. Apart from this, remember this unit ESU, electrostat unit. This is also known as Franklin. So if a question has this term, Franklin, this is actually the CGS unit of charge itself, which is ESU stat coulomb. And this ESU only has another name, that is Franklin. Benjamin Franklin was the scientist, so because of his, this name was given Franklin. What's the biggest unit of charge? This is important to know. The biggest unit of charge. Any idea? Anyone, any guesses, any idea? Actually, we have not discussed that. It's in capacitance. This is Faraday. Okay, this is the biggest unit of charge. Smallest unit you can make, this is the CGS unit. So see, the biggest unit of charge is Faraday. So if you have a question in terms of Faraday, or you wish to convert Faraday by seeing the options. See, in NEET, you just have to check the options and answer. In JEE exam, you have a section where you have to write your answers by yourself. But in NEET, you just have to take the options. So if you see options are given in Faraday, so remember, 1 Faraday is 96500 coulomb. That's it. This is the maximum possible questions that are possible out of the electric charge. Is it clear?
Yes, ma'am.
Okay, Jesleen and Ibrahim, please write it till here. And these are the properties of charges. Some things are already there, which you know, some things are extra. So please just write it and text me done once completed.
I'm finished.
Okay, let's move forward. See, here you have, after this, you have the methods of charging. So in methods of charging, nothing much is different in your NEET portion. Methods of charging. So at least you tell me, what's the first method of charging? Yes, anyone?
Charging
Charging by
of electron by
friction, right?
friction.
Charging, this the first one is charging by friction. When we say charging by friction, this just simply means charging by rubbing. The work is done against the frictional force and the valence electron gets transferred. So this is simple. We know whichever has the strong bonding will not allow the electrons to move and the other one will allow the electron to move. So charging by friction, I'm not going into the details of it. Second, Ibrahim, can you name any other?
Methods of charging, mom, like a power source, an actual power source.
Charging by friction, charging by any idea? Because okay, Ibrahim, it's okay. We didn't even discuss this with you. Charging by conduction. See, so Ibrahim, did you understand this one? Charging by friction.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
This one you've understood. Okay. See, in charging by conduction, you just put two objects in contact with each other. You connect them with the help of connecting wire, anything. And the charges, one thing that you need to now understand here, that the charge flow takes place till the potential is seen, till the electric potential is the same. So we haven't discussed potential. We have not discussed potential, but just keep it in your mind that electric potential is the same. Just think the way electric field is in vector form, electric potential is the scalar form. That's it. So charge flow takes place till the electric potential becomes the same. This is one point which is important to remember. And second, of course, that if the charges are identical, then the charge distribution. See, if you have objects identical, objects identical means they are exactly the same. So if objects are identical, they are exactly the same, then the new charge, the final charges, is given by Q1 plus Q2 divided by 2. This is the formula. That's it. This will give you the new charge on conduction. For example, if we take, let me give you one example. This example says there are 4 spheres. This is A, this is B, this is C, and this is having the sphere D. Okay, this has the charge 20 coulomb. This has the charge 50 coulomb. This has the charge minus 10 coulomb, and this is chargeless. The question says D is brought first in contact with A, okay, then B, then C. This is the question. This final sphere which is present, this charge D, let me write it here. D is brought in contact with A, then B, then C. Okay, and then it's removed. You have to find the final charges. So look, when A and D, they are brought first, right? D is come in contact with A. So this is A, this is D. So this is A plus D, A is 20, D is 0. So see, Q1 plus Q2 divided by 2. 20 plus 0 divided by 2, it's 10. So this is A, this is D. This becomes 10, this receives 10 coulomb. Now D is not chargeless. like it was initially. Initially, it was having the charge 0, but now the charge is 10. Now this D is brought in contact with B. So now let's see the next case. Now see, this is B. B has the charge 50 coulomb plus this D. What's the new charge on D? It's 10. So, Jesleen, can you tell me what will be the charges on B and D after conduction?
30.
How much, Jesleen? Your voice is coming very low. Please type, Jesleen, if possible. Yes, correct. Each will receive 30. This will become 30. This will become 30. How? 50 plus 10 divided by 2. So 50 plus 10 is 60, by 2 is 30, 30 each. This is how you have to check. Now D, which was initially 0, then gained 10, now is 30, is coming in contact with C. Now what's the case of C? This is C plus this is D. D is 30, C is minus 10. Ibrahim, can you apply the formula Q1 plus Q2 by 2? What will be the
Yes,
final
ma'am.
charge?
30 minus 10 plus 30 divided by 2. That's 20 divided by 2. 10, 10. 10 coulomb,
10.
10 coulomb.
Perfect. So C will also become 10 and this D will also become 10. So what are the final charges? Look, A has 10 coulomb. I am writing it here. A has 10 coulomb. B has 30 coulomb. C has 10 coulomb and D has 10 coulomb. This is the answer. Right? Correct?
Yes, ma'am.
Okay. Last one is charging by induction. In the methods of charging, the last one is charging by induction. So see, in charging by induction, we know when a neutral conductor is present, we bring inducing charges so that it attracts the charges. And what happens? By this, there is temporary electrification. Like if a conductor is present, on one side, negative charges will be accumulated. On the other side, positive charges will be accumulated. So this process is temporary electrification. But remember one thing, here nothing transfer has occurred. In charging by induction, there isn't any transfer, that we have not transferred the negative charge somewhere or the positive. It's just that this is only redistribution. Charges have aligned themselves in this manner. So this is important to know. Only charge distribution changes. The net charge will still be the same. Okay, here net charge will be the same. Okay, so that completes with the electric charges concept. Now we'll start with Coulomb's law. First, tell me till here, till what we have discussed, the electric charge, the properties of charges and methods of charging. It's clear to both of you?
Yes, ma'am.
Okay, please write it here, from here. Then we'll come to Coulomb's law.
Done, ma'am.
Okay. Let us start with Coulomb's law. So see, Coulomb's law, for a point charge, what's the formula? Ibrahim, can you tell me? F is equal to?
F is equal to K Q1 Q2 by R square, yeah?
Correct. K Q1 Q2 by R square. Now,
R
two
square.
things which you already know and which you both should remember, that is the value of K. This is 9 into 10 to the power 9 Newton meter square per Coulomb square. Also, you should know the permittivity of free space. That is the value of this epsilon naught, which is 8.85 into 10 to the power minus 12, right? And what's the unit? Coulomb square per Newton meter square, just inverse of it. Apart from this class, regarding the Coulomb's law, this Coulombic force that comes, it's a conservative force. It's a conservative force. It's a central force, and also it's a radial force. So these points are there which you should know. Apart from it, the rest of the details, you know that if a medium changes, it becomes K times. So dielectric constant and everything we will see later also. Now there is one question that has come a lot in the previous years. I'm writing the question. So see, this says Q charge is divided into two parts. Okay, Q has been split into two parts. So Q charge is divided into two parts and placed at r distance to each other. Okay, and placed at r distance so that the repulsive force, because see, this is the, when plus Q is split into two parts, both of them will be positive only. We have not induced another charge onto the second one. So the repulsive force between them is maximum. A question asks you, what is the value of this charge? Between them is maximum. So the charges of the two parts are. Look, how to solve this question? There is just one key term which is essential for you in this question. That is this term maximum. If you see the force is maximum, there is only one method which will help you, that is differentiation is going to help you. You cannot solve it this using simple Coulomb's law method that you use. See, Q charge is present. Question says Q is present. You have split it into two parts. Now, this is not saying two equal parts or what. First line, it is saying it is divided into two parts. So, let's say this is some part, let's say this is some X. So, the second part will become total is Q, so Q minus X. Okay, this is the force that we have. They are separated by a distance R. Okay, they are separated by a distance R. Now, usually when you have the forces maximum, the value of each part should be Q by 2. So try to remember this as a result also. But we'll prove it also. so that if a different question comes or if any modification is there in any question, you are able to handle that. Whenever it says force is maximum, first let us apply a normal Coulomb's law. These are the two charges, this is the separation. So if we are applying the Coulomb's law, F is equal to K. First charge, I have assumed it to be X. Second charge is Q minus X divided by R square. So if I just multiply this X, it becomes K. Qx minus X square divided by R square. Tell me, have I written it correctly till here? Is this right? This is how it has to be written. Now, what we are going to do, we are going to differentiate it. Okay? Differentiate force with respect to this value of X, means the charge F by Q. Right now, I have taken this charge, variable charge, or the charge that has changed as X. So dF over dx we have to. This is not, this X is not distance. See, right now I have this, assumed this as X, and this is Q minus X. This X is equal or not, this will be proven right now. So if you differentiate, see, you have K by R square, and this is the constant term, so it will come out. You are left with Qx minus X square. So see, from Qx, Q is the constant term, so Q will be there. X to the power 1 minus 1 is 0, and any variable to the power 0 is 1. Did you understand? See, understand this differentiation. It's like 3x. If I ask you to differentiate 3x, what will be your answer? What will you tell me if I ask you to differentiate 3x? Tell me. What's the answer? 3x. Differential of 3x. If we differentiate 3x, what will we get? Yes, Jesleen? Yeah, Ibrahim, answer?
Mom, 3. We'll get 3. Yeah?
3. You will get 3. So similarly, take Q as the constant because charge is a constant here. So that's why we are left with Q. Like 3x, you differentiate, you get 3. You differentiate Qx, you will get Q. And x square is minus 2x. Now this is equal to 0. Why? Because the force is maximum. This is something important for you to know. When the force is maximum, dF over dx will be 0. dF over dx means this charge. dF over dq will be 0. Now you have q minus 2x equal to 0. 2x is equal to q. X is equal to q by 2. Got it? So you can remember it as a result also. So when force is maximum, x is equal to q by 2. Is it clear? Yes, Jesleen, Ibrahim, have you understood this? Okay. Please write down the Coulomb's law part. Jesleen, Ibrahim, done? Okay, we'll continue it in the next class from Coulomb's law in vector forms and some PYQs we have to do.